Hello everyone, welcome back to the channel. Today I'd like to share about how you can think about measuring contract usage. So I've seen a few queries where they evaluate contract usage based on event log. So maybe the query goes something like this, right? Select contract address, and then I guess count one from the event logs table. So ethereum.core event logs, and then a certain timestamp, right? So they're evaluating, I guess there's a block timestamp here as well. No, something like this, right? So you're counting how much a how many times an event is emitted from a particular contract per day, right? And then you are saying like, okay, this particular contract address emits a lot of events in a day, so it must be of high usage, right? And while that may be true to a certain extent, I think the problem here is you're doing a count, and so it might not be a fair example, fair comparison. And I have a transaction here just to show you like what actually is an event. So if you go to Etherscan and you click on this gas tracker page, it shows you the top 10 or top 50 contracts that use the most gas, right? In the last 3 hours, 24 hours. And if I just click on Uniswap Universal Router, oops. So this contract is a Uniswap router that is able to route through all V3, Uniswap V3, and also NFT sales. Yeah, in this case, it routes through Uniswap V2 and also Uniswap V3 to find you the best swap for whatever this token is. But I've got an example here, I guess a simple example where someone swapped Wrap ETH for someone sold their America tokens to get Wrap ETH. Okay, and I am copy pasting this transaction onto Blocksec, or used to be known as Falcon. Right, copy paste here, right. Oops. Okay, so what this gives me is it gives me the what happens on the transaction on a trace level, right? On the traces level that is not easily accessible from Etherscan, right? Etherscan only shows you this much, but on a site like Blocksec, it shows you all these things. So what you're seeing here is all the possible things, or all things that happen under the hood, right? All things that happen when this particular person interacted with the Uniswap router intending to swap their American token for Wrap Ether. So under the hood, Uniswap, the universal router performs all these contract calls. Okay, we'll just go through them very briefly, right? So this initial 0 means this is the user that initiated the transaction, and then they initiated it on the Uniswap universal router contract. And so the universal router goes through several steps, or a bunch of steps. There's the permit call, right? A static call, and then because a permit, because the permit contract was called upon with the permit function. In the permit contract, they can code it such that whenever this permit function is called, emit this event. So an event is emitted, right? So that's how event relates to the traces or the contract calls, right? Events are emitted whenever a certain, I guess, function within the contract is called, right? And then whenever, and then in this case, when the swap happened, obviously the sender has to transfer their America tokens, and then they receive wrap ether in exchange, and so there is a call to wrap ether to be sent, right? And because there is a call, an event is emitted. And you can see not every call or not every trace call has an event. Like for example, in this case, they did a static call to get the balance of the USA token or the America token on the pool, but there's no event that's emitted, right? There's no there's no event emitted right after this. Right. So what that tells us is only certain events are not a sure thing, right? They are at the mercy of whoever wrote the contract, and they are only emitted during certain types of calls. Okay, so that's one. The other thing is gas, right? So whenever you call a contract, or whenever you call a contract, there's a certain amount of gas that's being used, and while events do use gas, this is not shown on the events level. Instead, it is shown on the trace level. And so if you want to compare contract based on gas, you will have to do it on the trace level, not on an events level. Okay, so going back to this, events, counting by events, not that good because you are, not all trace calls emit events, and also you cannot compare the gas used between contracts based on events. Okay, so those are two reasons. And so instead, how do we exactly, what are the ways you can think about measuring usage, right? Well, one way, as Etherscan has pointed out, is just by looking at the transaction as a whole. So for example, right, when they list here Uniswap universal router, what they're listing here is they're taking all of the gas that's being used in that transaction where the contract that you initially interacted with is Uniswap. So, which is exactly what this transaction is, right? This person over here interacted with this Uniswap universal router, right? I imagine there is a Uniswap interface where they click, they want to swap this much of America tokens in exchange for getting back wrap ether. And what Etherscan is doing here is it just takes the amount of gas used in the transaction. In this case, it is 169,000 multiplied by how much is the price of gas at that point of time, and then you get the transaction fee in ETH, right? And so they're just summing up ETH based on the to address, right? Or call it the origin to address. Okay, so that's one way, and we'll try to write a query to see how that works. So because we're looking at this page, which is the transactions page, we will need the transactions table. So go ahead, go to transactions, fact transactions. I've covered what all these tables mean as well in my beginner series, so you can definitely refer those in that video, but we're gonna jump right into it in this one. So what do I need from the transactions table? I need the to address, which is the address that the user initially interacted with. So to address, and I need the transaction fee. This transaction fee is denominated in ETH, so I'm just gonna sum the transaction fee, or I can sum the gas used. Gas. Okay, and then because they are doing it on a 24-hour basis, I'm also going to say get me the data from the last 24 hours. So this is the notation that we use, right? Well, black timestamp is in the past 24 hours. And then of course group by to address. I'll just group by all, easier. And then I'm ordering by transaction fee descending. So order by descending. Give me a little bit 20. So the top 20 addresses that people interacted with in the past 24 hours that people paid the most amount of transaction fee and used the most amount of gas. Alright, so we have these values over here. Let's just briefly compare this to what we see on Etherscan. Last 24 hours, about 98.98 ETH. This banana gun router, which is 0x332, and yeah, about 100 ETH 0x332. There is some latency, right? So that's why the values don't match up exactly when you count 24 hours. And then, but yeah, generally the contracts are the same, right? So this is Uniswap's router. This is the banana gun router, which is, I'm guessing, like a Telegram bot that lets you trade start meme coins easily. And then yeah, so on and so forth. Now you can join in labels to make it nicer, right? If there are names to it, but you can also manually name this based on what you see on Etherscan. So that's one of the metrics you can use, right? So instead of counting event logs, you sum the transaction fee and you sum the gas use. Okay. Slightly off topic, you can also do the opposite. So instead of asking which contract users interacted with the most and spent the most fees on, you can ask who spent the most fees on who spent the most fees. And so instead of using to address, you just change this to from address, and that gives you exactly who spent the most fees. Jared from Subway is a popular MEV team. Proposes a lot of blocks. Okay, so what else? Right? What else can we do besides this? So in this approach, what we did was we sum all the gas used in the contract and attributed it to the origin to address, which means the address that the user interacted with, to the original address that the user. Okay. What about what we just saw on BlockSec? Right, on BlockSec we see all these different contracts. So all these are different. All these are individual contracts which are different from the Uniswap router. So why are we attributing the gas spent on all these different contracts to the Uniswap router? Why couldn't we, sum all the gas used by all these contracts individually? The answer is we actually can, right? We can do that, but it gets messy because if the user interacted with Uniswap, are they really, are they really intentionally spending gas on Wrap Ether, for example? Not exactly, right? So that's why I think it just makes more sense from that point of view. But if you want to go the route of saying how much gas what contracts is used a lot in terms of whether it's on the back end or like users interacted with front end, just which contracts are used a lot in total, right? So if that's your question, then you can use the traces table. The traces table is it describes whatever you see here, right, on this BlockSec page. Excuse me. So let's So let's do a quick, select all from and then limit 10. Okay, so what is important here is the to address, which should be the, similar like transactions. It should be the contract that is interacted with. So to address, and then you have gas used, and I'm not going to exclude failure because if a trace fail, it still uses gas. So there's that. I think that's it, right? So to address and gas use, and applying the same logic here, where in the last 24 hours, group by all, which is just grouping by to address, and then I need the sum as gas use sum. Okay, now I need to order by the gas use descending. And again, this limit 20, right? So this will tell me which contracts are being used the most. Which contracts, are being used the most in terms of how much gas is being used whenever they are called, right? So it could be, right. For example, in our transactions here above, most of what we're seeing are this stuff user-facing contracts where Uniswap, Banana Gun, so on and so forth. If we look at traces in this case, what I'm seeing right here is this is WEF, this is Rep Ether, and users may not interact with Rep Ether as much as Uniswap, but when we sum the contracts this way, we're seeing that Rep Ether has used a lot of gas, or there's a lot of gas spent on Rep Ether being used. And the reason for that is because if you look again at this execution, when someone calls the Uniswap router and they want to swap for whatever tokens they want for WEF or the other way around, a call is being made onto the Rep Ether contract, right? This is the Rep Ether contract, to transfer Rep Ether from one account to another account, right? Or one address to another address. And so all these transfer calls require gas, and hence why it sums up. Also, another thing I'm realizing is that the gas used is a wait, is it? It might be like a sum. Okay, interesting. I guess a big caveat here to using a sum of gas used this way is that I think the gas used, let's say here, and it has a like a subtrace. I think the gas here counts in the previous trace, but I'm not sure. Something to check on. But yeah, if you're looking into I guess I should say, because you're looking at traces where all of the contracts are being accounted for, unlike events, you can also do a count, right? And this tells you how many times the contract is being used. Yeah. Or rather, how many times the contract is being called. And let's just change this to this and see what we get. Now, of course, you can join this with the labels labels table just to give you a name, right? So yeah, in this case, the WEF token is being called the most. Interesting. Let's see how to join the labels table. So I'm just gonna call this as with base as whatever this is, and then select all from base, left join. Because I know there are tokens here, I can also left join to contracts. But first, let's left join to the dim table. And the dim table is called address and address name. So I'm just gonna say on to address equals to address to address name, right? Okay. And if this doesn't tell us too much info, we can join on the dim contracts table again. Dim contracts table is it's pretty complete. Okay, yeah, whenever a contract is deployed, we can call the contract and see if they have the relevant metadata, like symbol, name, decimals is the typical things that a contract might have. Sometimes they don't, but you can join in again on dim contracts just to see if the labels, just in case the labels are not sufficient. But okay, you can see here, it seems like the top contracts by number of count are with USDT, right, USDC, so on. So yeah, definitely use transactions and traces. I feel like those are the two better ways to look at contract usage. For transactions, I think you can use gas use and attribute all the gas spent in that transaction to the to address, which is the address that the user initially interacted with. And then for traces, I think it's better to just use count. So you're counting the number of times a particular contract is being called in all types of transactions. Alright, that is it. I will include this query link in the description or in the comments. That's it from me. Thank you all for watching. See you on the next one.